Hello guys, Kevin here and welcome back to the Python series. So in the past few videos we talked about the operators in Python 3 and we did some basic mathematical and logical comparisons and all these things in Python. So in this video and upcoming 2-3 videos we will discuss more on the operations on especially numbers and strings. So we have for the operations of numbers we will talk about 3 modules: the math module, the random module and the statistics module. So in this video we will be talking about the math module. So let's roll the intro and start our discussion about math module. So get ready and get your machines ready and let's write some code. And before doing that, first let's understand the word module that we have been discussing. So what is a module? A module is a pre-written code, the code that is written by someone else that you can import into your project. Now first question that arises is why do we need to import someone else's code into our project? And in programming, one factor that is very important is reusability. Let's say you are planning to write some code on some project or some topic, right? But there are possibilities that particular code has been written by someone else already. So rather than writing that code again, you can directly import that code into your project and you can move ahead. Thus it will save your time as well as it will sustain the reusability factor. Okay, so that's why we can install some modules into our projects. Thus they will give us pre-written methods that we can use in our projects. So how to import a module into your project? So it has a very simple syntax. So get back to your machines, and the syntax that we need to follow to import a module is very simple. Just we need to write import and then module name. So this is the syntax whenever we want to import some module. So here we want to import a module named math. So let's do it. So the syntax again, import and then math. And right now it's grey out because we haven't used it into our code as of now. Once we use it, it will be highlighted again. So there are many methods in each of the modules. Okay, so it is not possible for me or any other instructor to cover all the methods. So what I will be doing is I will be covering the few methods that are used and that are very important, and rest you can explore into the Python official documentation. So let's start with the math module. So the few methods that are there, first what we will do is we will define a variable number and we will initialize it to value, let's say 25. So the first method that we will be discussing is math.log and we will pass here num, that is our variable. So what this method does is that it will return the natural logarithm to the base e, right? So let's see that whether it's working properly or not. For that we need to print it. So print, and let's print it and let's try running it whether we are getting a logarithm of that or not. See, yeah, we have got the log of 25, that is natural log of 25, that is 3.21 something. So the another method that is, let's first write and close it into print math.log10 and let's pass again num. So what this math.log10 does, that it returns the logarithm to the base 10. So let's run the code again, and here we have got as 1.397 something. So the first one, so here it is necessary to understand the difference. Math.log will return the natural logarithm and math.log10 will return the logarithm to the base 10. So let's move ahead and let's see another method, that is math.sqrt. And you might have guessed it right, that sqrt stands for square root. So it will return us the square root of the number. So we have passed here 25, the square root should be 5. And that's 5.0, so it is returning a float value. Okay, so let's move ahead and we will see the two important methods that are very used when you will be developing your web applications. So the first method is math.floor and another one is math.seal. Now what these methods do? the max.floor will round off the value to the closed lower value, and max.ceil will round off to the upper limit, that is the upper value that is close to it. So it might be a bit confusing, so let's implement it practically and then we will be able to see. So let's define another variable num2 and let's pass it 5.5. Now let's again print and here max.ceil and let's pass here num2. So as we discussed, it will round off and will give the upper limit. So let's try it. So here the answer should be 6, and yes, we are getting the 6. The value was 5.5, so it rounded it off to the upper limit. The upper limit is 6 and the lower limit is 5. So if we want the lower limit, that is 5, so for that we have the method floor that will give us the flooring value. So again math.floor and let's pass as num2 and let's try and run it, and here we have got the lower limit 5. Okay, so now let's have some more examples on some more methods. Another method is where sometimes we need the absolute value, right? If the number is negative, we need to find the absolute value, that is absolute values are always positive. So how to do that? For that, Python provides another method. So first let's define a variable, and these are very bad names that I am giving to a variable num2 num3. Please don't do that, give some meaningful names. So for now, for the teaching purpose, it's okay. So let's give it as -5, and then again let's write the print function, print and math dot and number 3. So fabs is a method that stands for the absolute value and it will return the absolute value. So in Python, the method's name is fabs, that is abs stands for absolute. So here we are getting 5.0 and the value was -5 and it's returning us 5.0. So let's write some more code now and let's take our discussion ahead. So another method that is if you want to find the factorial. Now what is factorial? Let's say you have number 5. So number 5 will be multiplied into all the numbers that are behind it. Let's say let's say you have number 5. So the factorial of 5 will be 5 into 4 into 3 into 2 into 1. So basically this is a factorial. So writing a code for it is not a very tough difficult task. It is simple, but again if already another person has written it, then we can reuse it. So again, math library provides us a very nice function, that is factorial function. So let's again do it, print and let's pass it math dot factorial and let's pass the value as 5. So the factorial of 5 should be 120. Let's see whether we are getting it or not. math.5 and factorial we have got it as 120. That's absolutely. Now let's try and find the GCD. GCD stands for greatest common division. I think if I am not wrong, and if I am wrong, you can correct me. And let's try that. So GCD math.gcd, and it will take two values, the two numbers for whom you want to find the GCD. So here we will take 5 and let's take 25 and let's run the code again, and we have got your 5. Similarly, we have two more methods that are a little important. So first let's try print and math dot, okay, not comma, dot, okay, and math dot power. Now what this function does is it returns the power. That's again it takes two parameters, x and y. And now what are these two parameters? It will return x raised to y. So let's say our x is 2 and this is 3. So it will return us 2 raised to 3, 3 raised to 2, because it is x raised to y. Okay, so 3 raised to 2. So let's run it and we have got it 8. Okay, so basically it is x raised to y, that is 2 raised to 3. 2 raised to 3 is 8. Okay, so now let's try a few more methods. Print math dot degrees, and let's say we have 100. Okay, so what it is doing, math dot degrees, what it will do is it will convert a Celsius into degrees. Okay, so 100 Celsius will be something 5729 degrees. So again, let's do the Celsius one. Sorry, and not Celsius. I am wrong here. What it will do is the 100, the value that we passed, it is an angle, not the degree and Celsius one. Sometimes we get confused in it. That's what happened right now. So let's try and understand it again. Sometimes it happens. So what we do is we pass on a radian value to a degree. If let's say you have a radian angle, then it will convert it into degrees, and let's say you have degrees, it will convert it into radians. So here the value that we passed was 100 radians and the degrees for it was written. Now let's do the reverse thing, that is math dot radians, and let's pass it 25 degree and let's run it. So it is returning 0.43 radians. Okay, and one more most important thing that math library provides is a constant variable math.pi. If you are from a mathematical background, then you might know what is pi. Pi has a constant value of 3.14 and something otherwise, or 22/7. So that is provided by math library as well, and it is of the form math.pi. And remember, as I told, it is a constant variable, so it is not a method, so we are not passing here any parenthesis, it's a variable. And let's try and run it. So there are instances when you need all these things, like here first, let's see the output we have got as 3.14. So there are instances where sometimes we need some pi value in our calculation, or we need to convert some into degrees, or above all this, let's say your requirement is some decimal value or the positive value, and client is entering some negative value, so you can convert it into by using the absolute method. So this functions comes in handy and are very simple, so you keep on practicing, and there are many more methods, as I said, that you can explore it on the Python official documentation. So let's catch up in the next video, where we will be discussing about the random library and the statistics library. So if you love, and one more thing, if you are loving this Python series, then please hit that like and the subscribe button. That will keep me and my team motivated to put on many more videos and many series. So let's catch up in the next video.